So we're just going to do a couple quick problems to show you the equivalence between Google Sheets and a TI84 graphing calculator. So right now we're going to try and find the area between 5.6 and 5.74 on this standard normal curve with a mean of 5.67 and a standard deviation of 0.06. Here's what it would look like on Google Sheets. You have to find the area to the left of 5.74 and then subtract off the area underneath this curve to the left of 5.6. So there it is written out in hand. Let me show that to you up here as well with Google Sheets. So here's the one area, here's the other one, and here's their difference. Of course, you can write that all on one line as well. But what does it look like on the graphing calculator? On the graphing calculator, things are a little bit different. First of all, to find your commands that deal with distributions, you're going to go to this key. But we need distributions, which is above that in blue, suggesting that we need to hit the second key here. So second, and then distributions. You want the normal CDF. Do not use the normal PDF. So let me scroll down here one step. And if you've got a nice up-to-date TI84 and you're like, oh my gosh, I don't remember how to use this command, then the nice thing that you can do is hit the plus key. And that'll tell you, oh, you're going to type in the lower bound and then the upper bound. And then if you want to, you can put comma, mu, comma, sigma. That would be the mean and standard deviation. If you don't put anything other than the lower bound and the upper bound, it's just going to give you the standard normal curve. So it's going to assume that you're talking you're talking about the curve with a mean of 0 and standard deviation of 1. So let me paste that in. And let's do between, let's say -1, comma 1. Now, if I put a parentheses, it's going to assume that I have the standard normal curve, mean of 0 and standard deviation of 1. So bam. There we go. From the empirical rule, we see that that matches. We have about 68% of our data within one standard deviation away from the mean. How about this one, though? This actually gets easier with the graphing calculator, this one in particular. So I want to find the area between those two. So let me go back to my calculator. Second, distribution. Now, if you've got an up-to-date graphing calculator, this should be a menu-driven problem. If not, that's okay. You can type it in with a comma. So the lower value that I want is 5.6, or you can type in 5.60. Then the upper value is 5.74. 5.74. Then we're going to type in the mean and standard deviation. Mean is 5.67. Standard deviation is 0.06. Then paste that in. So if you've got, say, an older TI83, then you would just type in the command as you see it here. It'll be normal CDF, then 5.6, comma, all this stuff. We get exactly the same answer that we got on Google Sheets. 0.7566. So great. So hey, why not always use a graphing calculator? Well, it gets a little bit tricky to use a graphing calculator in certain instances. For instance, what if I wanted to try and find the area just to the left of 5.60? Well, then I got to think a little bit harder because the area to the left of this, I've got a right bound, but what do I put in for a left bound? Because the graphing calculator works by giving you a right bound and a left bound. Let's look back at that and see what I'm talking about. Second bars or second distribution, however you want to see it. Go down to normal CDF. What do I put for the lower bound? If I'm talking about essentially negative infinity. Well, you just got to give the calculator a value that's far enough to the left that it's really not going to make a big difference. So choose something like -100, -1,000, -10,000, whatever you want. As long as it's pretty far out the left, then it's really not going to make a difference. So let's take a look at that. I'll put in negative, I'll do 10,000. That's my stand-in for negative infinity. The upper bound will be 5.6 in this case. Mean and standard deviation are the same as they were. Paste that in. And now I see that about 12.12% or 0.1216 of the area is in that left tail. So that matches what we expected. If I want to do the same thing for something in the right tail, then I can do that. My lower bound is going to be 5.74, and then I got to come in with some kind of a stand-in for infinity. So another big number like 10,000 or 100,000 or a million, whatever you feel like typing in. Let's go try that. Let me clear out all my keystrokes so that you can follow along. Second, then the bars key. I'll just type the number 2 this time. My lower bound is going to be 5.74. So that corresponds to the lower bound. The upper bound is infinity, but I can't type that into my calculator very easily. So I'll type in a very, very rough approximation of infinity. I'll type in 100,000. Mean and standard deviation are okay. This should be the area in the right tail. Yay, about 12.1216%. Now there's some other things we did with these kinds of problems as well. That is, sometimes you wanted to specify an area and then work backwards. So in Google Sheets, that was norm inverse. For instance, in one of our problems, we wanted to find the point that 2.5% of the area was in the left tail, and then the other one was just 2.5% of the area in the right tail. So let's take a look at that on Google Sheets. Excuse me, on the graphing calculator. Again, let me clear out some stuff. We're going to go back to our distributions key, or distributions menu. This time I want to use the inverse norm. Let me go down here and hit the plus key and see what the form is of that command. So first you're going to type in the area, then you're going to type in the mean and standard deviation if they're different than the standard normal curve. You also have the option of typing in what part of the normal curve, left, right, or center. We're going to shy away from that a little bit, but let me paste this command in and give it a whirl. So if I wanted to try and find the area in the left tail, so that I had 2.5% of the area in the left tail, then I'll type in 0.025, comma, and then the mean, which is 5.67, and then the standard deviation, which is 0.06. I should get 5.55. Yay, that matches what I expected. If I want to repeat this and get the other point, so that 2.5% of the area is in the right tail, what you have to realize is that it's really going to mean 97.5% of the area is in the left tail. So let me repeat my calculation. Go back to the distribution menu, select the third option down. This time I'm going to do it with a menu-driven option. Let's see, area, well, let's do 0.975. The mean is 5.67. Standard deviation is 0.06. And I want the area in the left tail. So I'll go all the way down the bottom and paste. This time it put in the left for me, and that's great. If you do get this menu-driven option, when you go to that menu, then good on you. Let me show you one last thing that you can do if you do get that menu-driven option. Instead of having to think, oh, gee, it's 97.5% of the area in the left tail, what I could do is just say, oh, well, I don't want to think about it. I want 2.5% of the area in the right tail. And then just go specify that, gee, this has to be in the right tail. Enter, and bam, getting the same thing again. All right, hope that helps straighten out a few similarities between different commands, and that you can do this on your own if you need to. Good luck.